Hello and welcome back to College Algebra, MAT 150. In this lecture we will be discussing horizontal asymptotes. So given a rational function, again a rational function is one polynomial over the other, if we want to talk about the horizontal asymptotes and we want to find them, all we have to really do is look at the leading terms. So ax to the m, we're going to assume this is the leading term of the numerator, and bx to the n is we're going to assume that's the leading term in the denominator. So the a and b are the coefficients, and the m and the n represent the degrees of these polynomials. So we have three possible choices given what the degrees of the polynomials are. If the numerator is smaller in degree than the denominator, then as it turns out, the horizontal asymptote is always y equals 0. If that's the case. If they're equal, then as it turns out, it's y equals a divided by b. So again, both are horizontal lines, represented by horizontal lines here. But if the degree of the numerator is larger than the degree of the denominator, then we have the case where there is no horizontal asymptote. And the reason because of this is there's many different asymptote types that could occur. Normally, if it's 1 degree bigger, then we'll have a slant asymptote. However, it could be a quadratic, cubic asymptotes. It has all kinds of flavors. We have all kinds of flavors of asymptotes that could sort of pop up. All right. So let's now look at some examples. So we're going to be comparing, and again, the horizontal asymptotes are pretty nice. The vertical asymptotes, as we talked about in the last lecture, we have to look at the denominator. So let's check this out. So if we're going to determine the vertical and horizontal asymptotes of the given function, let's start with number 1. So let's indicate with each time we're finding an asymptote which ones we're finding first. The horizontal asymptotes, so we look at the degree of the numerator and the degree of the denominator. The leading term here is 3x, and the leading term here is x. This is of degree 1. Again, that's the exponent there, and that's not written. And the exponent for that one is also 1. So what is, if they have the same degree, what is it? Well, it's the coefficient over the coefficient, the leading coefficient over the leading coefficient. So the leading coefficient here is 3. The leading coefficient in the denominator also, if it's not written, it's assumed to be 1. So 3 divided by 1, which is 3. And this is the horizontal asymptote. All right. Further, for vertical asymptotes, at the end of the last lecture, we talked about just finding the factors and setting those equal to 0. Well, of the denominator specifically. So for vertical asymptotes, we set the denominator equal to 0 and look for factors that are also not in the top. And so we're just going to solve here. We got x equals 5 is the vertical asymptote for this function. So y equals 3, x equals 5 are our asymptotes. What about number 2? Well, let's go through and let's start with the first thing just like what we did over there. Let's look at the horizontal asymptotes first. And what do we do? Well, we're looking at the degree of the numerator over the degree of the denominator. The degree of the numerator is degree 1. The degree of the denominator is degree 3. So here, m equals 1, n equals 1, and so m equals n. So we're able to put that over there. But here, in the top, m is of degree 1. Again, that's the exponent. And in the denominator, it's n equals 3. Again, that's the exponent there, not the coefficient. And so since m is strictly less than the numerator, so the degree of the numerator is less than the degree of the denominator, excuse me, that should be an n, then we say that we have a horizontal asymptote of y equals 0. That's it. No computation. What about for vertical asymptotes, though? Well, look at the denominator. So 3x cubed plus 2x squared. And we find a full factorization. So we can factor out the x squared, and that leaves us with 3x plus 2. And what do we do? Well, the x squared and the 3x plus 2 are not in the top, so that they're unique. And what we can do is we can set them equal to 0. So set each factor of the unique factor of the denominator equal to 0. Unique as in not also being in the numerator. And solve. Well, we have the factor squared. We can just set the inside. So x equals 0 is one of the vertical asymptotes. And here we have to solve. Subtract 2, divide by 3 to both sides. X equals negative 2/3. And this is our other vertical asymptote. So x equals 0 and x equals negative 2/3 are our vertical asymptotes, and y equals 0 is our horizontal asymptote. That concludes this lecture.